Good day all. Scott Norina here again. In this video I will discuss the how and why I am considering to change the production architecture of my web application, subs2go, to run in Docker containers. What is Docker? Docker is an open source platform that automates the deployment of applications inside lightweight, portable software packages called containers. It allows developers to bundle an application together with all of its necessary parts such as libraries, dependencies, and configurations into a single package. This ensures that the application runs reliably and identically on any computing environment, solving the classic problem of "it works on my machine." What does the subs2go application do? Subs2go is an employment website for fitness instructors. This web app includes a database repository of fitness instructor professional profiles. Instructors can log into the app through a web browser or smartphone to manage their professional credentials and set their availability for work. Employers may search our database to find instructors using a variety of search parameters including fitness discipline, work location, and availability. When an employer finds a suitable candidate, they may send a message to discuss the details of a work opportunity. How is subs2go currently deployed and managed? This application is configured to run as services on a Linux VPS virtual private server. Subs2go consists of 3 component services including an Apache2 web server, Java Spring Boot application, and a MySQL database server. Each of these applications were installed and configured separately on a Linux OS runtime. Start and stop of each application is managed by the Linux systemd service manager. I use Secure Shell to log into my remote server to manage all aspects of my web application. Query of the status of my subs2go service using systemd shows the run status of my Java Spring Boot application. As mentioned, there are 2 further running essential services including the Apache2 web server and the MySQL database server. All of the files used by my application are saved in the home folder on my Linux VPS. In this folder, I also include a convenience bash script that I use to show the runtime status and listening port assignments for the 3 component services that function together as the subs2go web application. Notice that the Apache2 HTTP web service is running and listening for web traffic on port 80. Port 80 is the default port used for traffic on the internet. The purpose of the Apache2 server is to act as proxy, redirecting external internet traffic on port 80 to port 8080 internally on the server. The Java Spring Boot service is also running and configured to handle the forwarded internet requests on port 8080. Spring Boot uses an embedded Tomcat web server to handle HTTP request methods. Port 8080 is the default port assignment for Tomcat. Lastly, the MySQL database server is also running and listening for queries on its default port 3306. In production deployment, external internet requests on port 80 are forwarded by the Apache2 proxy server to port 8080 and handled by the Tomcat server embedded in the Java Spring Boot application. The application in turn pulls requested data from the MySQL database on port 3306. The app builds the response including requested data and returns web pages to the user over port 80. Even though this setup works well enough, it is difficult to maintain given the need to install and configure each service application separately, including management of configuration files and dependencies. Furthermore, setting up the application components to run as system services adds yet another level of complexity. If it were necessary to change to a new hosting provider, it would be significantly more work to duplicate all aspects of the application set up in a new server environment. On the other hand, the same application could be cloned with Git on another server and launched with Docker quickly and easily. In Docker, all of the services that make up subs2go are packaged together and run in linked lightweight runtime containers. Here I will navigate to the source folder on my development machine for subs2go Docker and open the main configuration file in my integrated development environment, LazyVim. Each of the component services and their respective configuration details are defined in the Docker compose file and respective Docker file. All other resources used by the application are packaged together in a single source folder and persisted to a GitHub repository. In this way, the Dockerized application can be cloned onto any operating system that has Docker and Git installed. Launch of the full application is a simple matter of running the command docker compose up-d on the command line. On first launch, Docker will read the configuration details for each service listed in the Docker Compose file, build a runtime image, create a runtime container based on that image and start the container service. The individual images represent a blueprint for the container runtime environment including all required resources and dependencies. The image files for each service would only need to be rebuilt to reflect resource and/or configuration changes. Docker provides easy methods to rebuild images. Notice that the Compose file also includes information of the listening ports. The images for each service are already built on my system and can be viewed by running the command docker image ls. Run of the command docker ps will show the run status of each container including the defined listening ports. The application is now running with the Apache2 proxy web server listening for web requests on port 80 at localhost. In order to see information of the application's launch status and performance, we can tail log files from the Java service in the terminal window by running the following command, docker logs-f followed by the container name. Now we can open a web browser and enter http://localhost to open the home page of the Dockerized application. We may also log in to view a user profile. Here I will enter the login credentials for my test user account. The splash page will show the profile picture and dashboard icons for the test user. Nice hat! I will click on the profile icon to navigate to the user profile page. If we return to the terminal window, we can view the tailed log entries output by our Java Spring Boot web application. In production, our web domain name subs2go.ca is configured to point to the IP address of the remote server running our Dockerized application. In summary, Docker provides a solid solution to simplify management and deployment of applications made up of component services and resources. Thanks for watching.